Dilation and reflection. Well, we talk about dilation first. So what is dilation? Is you stretch something or you compress something. For example, there's a graph like this, and we can stretch it up. If I said, for example, I have a point. 1, 2. If I stretch it in this direction by 2 times, okay, vertical direction by 2 times, the point will become 1, 4. The x will remain the same, and if you stretch it longer, okay, 2 times longer, so the y value will be times by 2. Or if you stretch in the horizontal distance, like stretch this way by 2 times, we will have, well, 4 times. Let's say we stretch it 4 times, we'll have 4, 2. Because we times the x value by 4. So it depends on which way you stretch the graph. Or you can compress it. Okay, we compress it that way. So you will be halved. Like for example, a half, 2. So we can make 1, 1. We compress it this way. Okay, vertically a half. So it will be 1, 1. If we compress this way by a third, so it will be a third, 2. So this is called dilation. So we stretch things or we compress things. Okay, but the way we describe it is very tricky, and you need to be careful with the language. And when you describe it, you must give one of the right notation. So there are 3 ways to talk about the stretch. The first one is stretch in the parallel. Okay, the first 3 is talk about the horizontal stretch. Yeah, that way. The y value won't change. It's a horizontal stretch. The next 3 is talk about the vertical stretch. Okay, stretch that way. Okay, let's see the horizontal stretch. If you want to talk about the horizontal stretch, what you will say is a dilation by a factor A from the y-axis. Can you think about y from the y-axis? It's like you fix this y-axis, you stretch it away from y-axis. Can you think about that? You stretch it this way. That's why it's called from the y-axis. So the distance from x doesn't change, but your distance from y does change if you stretch in horizontal way. So that's why we said it's from the y-axis. Okay, so from the y-axis. That's the first way we talk about it. The second way we talk about it is it's all by a factor of A. Or we can say parallel to the x-axis, right? Horizontal stretch parallel to the x-axis. Or we can say in the direction of x-axis. Okay, in the direction of x-axis. So parallel to x-axis, in the direction of x-axis, or from the y-axis. Okay, it's opposite. When you say stretch from the y-axis, is actually change x. Okay, all of those 3 change x, but the first one is a little bit tricky because they mention y, but it's actually changing the x values. That's a common mistake. Students will think, oh, that's maybe changing y, but it's not changing y. From y is actually changing the x values. So all of these 3 is the same thing. Okay, these 3 are the same, exactly same thing, and it's all changing the x values and it's changing the horizontal distance. Okay, horizontal distance that way. First one is normally the one you use. Okay, first one is normally the one you use. When you describe things, you say there's a dilation by a factor of 2 from the y-axis. That's normally the one you use, and that's the common one the question will use. Okay, in the question they will mention the first one, but they can also use the second one and the third one. So you need to know like what they means, and you need to know they are the same thing. Okay, they are the same thing. And they mention anyone, you know what is changing. It's actually changing the x values for all of these 3. And okay, if I dilate by a factor of A from the x-axis, so its x will be times by A. So you knew x. This is the mapping. Okay, this is the mapping. You knew x will be old x times by A. That is the mapping. That sentence will give you. That sentence will tell you the new x will be old x times by A. Okay, it's changing x, and it's the old x times by A. The y value won't change. Okay, y value won't change because that's the point. You stretch it away from that, the height won't change. So the y dash will stay as y, but x dash will be A times of the original x. So similarly, we have the vertical stretch. We stretch this way. In this case, the x won't change. The y will be either moving up or compressed, like shorter. So the mapping we can have is y dash equals to by, and x remain the same. Okay, x remain the same, but y dash equals to by because it's stretched that way. Again, from x-axis is changing y value. Or say parallel to the y-axis, like that way, or in the direction of y-axis. You need to memorize those three ways of talking about dilation. So the language for dilation is more complex, okay, more complex compared to the translation. Three ways we can use, and you can choose any one to use, but I will recommend the first one because that's most of the paper will use the first sentence to talk about it. But in some case, they can also use the second one, third one. You need to know what they mean. Okay, which one, what they change. They change x or they change y. That's what you need to know. Okay, that's the mapping for dilation. Very easy. Okay, it's only times the number. But you need to choose the correct variable to times the number. Let's see one question first. Let's have a look at example 1. Okay, write down the equation of the image. Okay, equation of image is question mark. Obtained when y equals to 1 over x squared is transformed by a dilation of a factor of half from the y-axis and the dilation of factor of 2/3 from the x-axis. Okay, which type this question belongs to? Like the 3 type, which type this belongs to? The first type. You know 1 and 2 and ask for number 3, right? So if I have number 1, number 2, and number 3. Okay, let's make it quicker. So y equals to 1 over x squared. This is my question mark. Okay, what I can write for number 2? Can you directly give me the mapping? Well, that's the transformation description, right? So what's a dilation of a half from y-axis means? What equals to? X dash. A half x. Good. From y-axis is changing the x value. So that's x dash. New x is a half of the old x. Okay, a dilation of a factor of 2/3 from the x-axis. What we can write? Yeah, y dash equals to 2/3 y. That's what we can get from number 2. That's the mapping. Okay, that's the mapping what we get from number 2. And because we get 1 and 2, we want 3. So this is the substitution. Okay, that's the substitution. What needs to be the subject in order to do substitution? Y and x, right? Y and x. So I need to rearrange it. X will equals to 2x dash. Y will be 3 over 2y dash. I want to replace this y, replace this x. Therefore, I need to make xy to be the subject. Therefore, I will put y as 3 over 2y dash equals to 1 over x squared. Okay, what's x? X is 2x dash. And then squared. Okay, we can rearrange that. If we rearrange that, that's y dash equals to 2 over 3 times 1 over 4x dash squared. Okay, this 1 and this 4 can be cancelled. That's 1, that's 2. So y equals to 1 over 6x squared. When you write your final answer, you don't need to have the dash in it. You just, that's like more like you're working, like I want the equation in terms of x dash and y dash, but I can get rid of the dash in the end to answer the question. So not necessary to keep the dash there. But if you want, doesn't matter. You can keep the dash, or because the dash really looks like a power of 1/12, like 1/12, so it looks bad. So I will just get rid of the dash. After the simplification, I will have y equals to 1 over 6x squared. Okay, 1 over 6x squared. Any questions? This is only involved dilation, okay? Only involved dilation. We'll talk about the combination one tomorrow, but I'll just skip that one yet. I'm not going to combine it now. So that's the dilation, okay? Dilation from x-axis and dilation from y-axis. And we can see that's still the same type of question as what we done yesterday. We have 1 and 2, we work for 3. And the only thing changes the middle, like the mapping, like the mapping equation, what you can write for the equation. So that's this example here. And let's go to the top. Okay, let's go to the top. We talk about reflection. Well, reflection is the easiest one, I think. Reflection is describing the mirror image. Okay, we have a point 1, 2. Reflect in the y-axis, what I will have is negative 1, 2. If I reflect in x-axis, is 1, negative 2. So reflect in the x-axis is changing the y value. Reflect in the y-axis is changing the x value. Do you agree with that? Yeah. So it's only one way to describe it. Reflect in the y-axis or reflect in the x-axis. Okay. So reflect in the y-axis is change x. Reflect in the x-axis is change y. So it's always the negative of the original. Okay, it's the negative of the original. So change x, reflect in y-axis, new x become negative of old x. Reflect in the x-axis, change y. New y equals to minus of old y. So that two things are what we will write. Okay, that two things are what we will write. X dash equals to minus x and y dash equals to minus y. That's it. Reflection easy. But what I want to mention is dilation. We only dilate by positive value. Okay, we only dilate by positive factor. We will say we dilate by a factor of 2, dilate by a factor half, dilate by a factor 4. But we're not going to say dilate by a factor of negative 2. If you say there's a dilation by a factor of negative 2, the negative must be a reflection. When you see negative in your mapping, that must mean a reflection. That's not going to be dilation. Okay, dilation can only be positive factors. We say dilate by a factor of 2, a half, 3, 4, 5, but we won't say negative of those values. The negative must mean reflection. Okay, it must mean reflection. So if you see mapping like x dash equals to minus some x, it must be a reflection in the y-axis. The minus won't be combined with the dilation. That's something you need to be aware of. And let's keep going for example 1, question 2. Okay, so still write down the equation for the image obtained by that graph when transformed by reflection by the x-axis and reflection by the y-axis. Well, reflection is 2 reflection here. We still have step number 1, step number 2, and step number 3. Okay, we have a original equation as y equals to 1 over x squared. That's number 3 is what we're interested in. What we can write for number 2. Okay, reflect by x-axis, what we can write. Reflect by x-axis. Y dash equals to negative y. Okay, remember reflecting x is, well, yeah, I know like you have y equals to negative y dash, x dash equals to negative x for both, but order is well, order is not really important in this case, but I want you to make sure reflect in x is changing y value. Okay, reflect in x-axis is changing y value, and reflect in y we will have x dash equals to minus x. Okay, that's reflect in the y-axis. Okay, again, same as the previous question, I want to do substitution to replace the y by y dash, replace the x by x dash. So we need to make y equals to minus y dash and x equals to minus x dash. Rearrange the equation to make x, y to be the subject in order to substitute. So when I substitute, I will substitute minus y dash in replace y and 1 over, okay, bracket x is minus x dash, and then we square the whole thing. We squared x is the same as we squared the minus x dash. And you can see if we rearrange it, we will have y equals to minus 1 over x squared. The bottom will just become a positive x squared, and you put the minus to that side. It's a minus 1 over x squared. That's the new equation. Any questions for those two? Okay, if you don't have any questions, example 2, I'll start example 2. Before I start example 2, this question is not a hard question. I think most of us can easily answer it now. But what I want to do is discuss this question a little bit and give you more, like, think about more about dilation. I also change this question a little bit. Not change. Well, this won't change. Okay, y equals to root 2x become y equals to root 3x. That won't change. And I also talk about the dilations in between, or reflections in between, transformation in between. But I want to ask in two parts, part A and part B. I will do. Okay, I'll fix the sentence for you. This is a dilation by a factor of what from the y-axis. That's my part A. Part B is dilation by a factor of what from the x-axis. I can make it even harder, like dilation by a factor of what from x and from what from y. I can make two dilations as well. But let's think about the easier one first. A is the easier one. If it's actually this two sentences makes the question harder. It already fixed a dilation direction for you. Okay, fix a dilation direction for you. Okay, according to what we learned yesterday. We have number 1, number 2, and number 3. Okay, number 1 is y equals to root 2x. Number 3 is y dash equals to root 3x dash. I want to have x dash in terms of x and y dash in terms of y in order to talk about the dilation, reflection, and translation. Okay. First of all, we think about the rule. What's the rule of this function? What's the function? What's the name of the function? Is that okay? Do we need to rearrange the function? Can we equalize it directly? Yes? Okay. If we equalize them directly, we will have y equals to y dash and 2x equals to 3x dash. Okay, that's how we equalize them. I don't care about the root itself. The square root I won't include it. It's the thing I insert in it. I will equalize them. So it's like more like the people in the house will equalize them. Okay, what needs to be the subject? X dash y dash. We need to describe it. We want to see new equals to what old. New equals to what old. So y dash equals to y. There's no change in the y side. Okay. So they're the same. Y value doesn't change. There's nothing happened to the y side. X dash equals to 2 over 3x. We divide 3 on both sides. X dash equals to 2 over 3x. Okay, according to this, how you can describe it. What's the transformation? A full sentence, like dilation. 2/3 from y-axis. Okay, so that's the answer here. That's a dilation by a factor of 2/3 from the y-axis. That's this one. Okay, that's this one. All right, easy to answer part A, but hard to answer part B. Part B says dilation by a factor of what? From the x-axis. Well, I can't see any dilation from the x-axis, right? The y won't change. I can't see this. Also, I can only see dilation from the y side. So what we can do, okay, this is thinking what we can do. I don't want the dilation happen to x. I want the dilation happen to y. Therefore, the coefficient of x must be 1 for both, or must be the same for both, which means there's no dilation, nothing to do with the x. Okay, so remain the same. What we can change to this question is y will equals to √2 times root x. Y dash will equals to √3 times root x dash. Can you see that? Okay, this function to that function. Why I'm doing this? I have made the coefficient of x all become 1. Okay, they make the same. There's no change to the x. And also do remember, I said I will only keep the rule on one side. Any coefficient will move to the left. So that's the rule. That's the rule. Everything else will move to the left. So y over √2 will be root x. Y dash over √3 will be root x dash. Can you see that? The number is actually go to the y side. It's actually changing the y value. There's no influence in x. Okay, I get rid of the number from the x side. So now when I equalize both sides, root y plus that, and x just equals to x dash. There's no change to that side. Okay, there's no change to x. Nothing to do with x. X just equals to x dash. No change. But my y dash equals to √3 over √2y. Okay, times √3 on both sides. √6 over 2 times y. What you can say? According to what we get now, what you can say? Yeah, from x-axis this time. So this answer will be √6 over 2. There's no change at all from the x-axis, but there's only change from the y-axis for the first one, and there's only change from the x-axis for the second one. Okay, what this question tells us, why I'm changing the question, what this question actually can tell us is there's more than one way to do dilation always. This is not the only two ways we can do it. We can also be a combination, dilate something from x and then something from y. Okay, there's infinitely many ways we can do dilation. Okay, just give you two graphs, that graph to that graph. If it can be achieved by one dilation method, it definitely can be done by another dilation method. It must be done by another way. Okay, so this is only two examples, two ways I show you. Dilate only from the x-axis, dilate only from the y-axis. That's the two methods you can see. There's more than this. Okay, infinite many ways we can do it. I'll just give you one example, like one thinking. If I keep y equals to √2x, and this side become y dash equals to √3 times root x dash. So this side is perfect enough, the 2x together. But this side, the √3 needs to move to the bottom and times root x dash. So this side still keep like this. Now y equalize it. Y equals to y dash over root 3, 2x equals to x dash. That's how I equalize them. Y dash will be root 3y and x dash will just be 2x. Can you see the dilation? This is a dilation. Okay, this is a dilation by a factor of 2 from the y-axis and by a factor of root 3 from the x-axis. Okay, you see this example shows you that it's actually dilate by 2 directions. Okay, the A and B only dilate by 1 direction, but this one actually shows you can dilate by 2 directions and get it. But all the dilation factor will be different. It won't say, oh, I dilate 2 from the x-axis and I'll still dilate 2 from the y-axis. They won't be the same. Okay, it won't be the same. You can dilate by different factors from different axes to get the same thing. Yes?
So it's not like what A and B, you do first A and B and then you add it to A? And
You add it to A or B and this is C. Like I can say that's C. So it's all different. Like all of these 3 methods, you achieve the same thing. Like you end up with the same, well, start from root 2x, end up with root 3x. So you will achieve the same result, but they're all different ways to describe it. So we can dilate only from the y-axis, I can dilate only from the x-axis, or I can dilate a mix. Okay, some from x, some from y. And this is not the only thing. You can see you can change different numbers and make different coefficient and I can get different things. So this question shows, well, not only square root, all the questions involve dilation can be dilated by different ways. Okay, can be dilated by different ways. If can be dilated, like say 2 from the x-axis, definitely can be dilated by another factor from the x-axis, but the factor won't be the same. Okay, factor won't be the same. It will change. This is what you can see from this question. Why I'm talking about this question here? Because in some tests, they will set a way for you already. Like my part A and part B. They will say, this to this is a dilation by a factor of what from x-axis. They already set up the direction for you, and you need to choose, like a multiple choice question. You need to choose the correct direction. Okay, you need to choose the correct direction. So that can be one of the questions. I can put this on multiple choice and say, this graph to this graph is a dilation by a factor of what from the x-axis, and ask you to do that. Okay, so that's the type of questions you may have in the test. Okay, I'm not going to continue with the next one today. So we up to exercise 7b. Okay, up to exercise 7b. Tomorrow we will talk about this one. Okay, we'll talk about this one. You can have a look at the questions to think about it, but you don't need to really do it. After I show you one example, it will become really easy. Okay, it will become really easy. All right.